explain how to graph these logarithmic functions, because sometimes when there's lots of words, then our mind just goes blank and we don't even think. So whenever we have a log function with base b, as long as that base is greater than 0 and not equal to 1, these things happen. Okay, so main thing is these 3 points happen right here. And it makes sense because if I switch this to exponential form, and this is just y, right, basically, wouldn't it be b raised to y equals x? So if I plug in 0 for y, right, if I plug in 0 for y, isn't anything raised to 0 power just 1? So that's why I have this point, 1, 0. 1 for x, 0 for y. It's just kind of backwards, right? And I always have this point because if I put in 1 here, b to the 1, isn't that just b? So my x is b and my y is 1. And then same thing here, when I plug in a negative exponent in, isn't that just a fraction, right? And these exponents, because it's in this form, the exponents are actually your x. So as long as you can identify what your base is, and that's greater than 0 and not equal to 1, you can just find these 3 points and graph this. Pretty simple. It's continuous, meaning it keeps on going down to the left and keeps on going to the right. My domain is my x's, right? That means I can't go on my x's, which is here, because if I keep on putting negatives here, like -2, don't I just get a smaller and smaller fraction, right? So that means that it's only from 0 up. Okay, and then my range, it keeps going down. It just never crosses that vertical asymptote there, right? And then it keeps on going up there. So that's why the range is from negative infinity to infinity. Or you can write it like this. You can write your domain like that, or you can say these things, right? The asymptote is y equals x, and then on the x-intercept, and there's no symmetry. Okay, so those are the things in end behavior we'll get to on the next problem. So that's basically how you graph these things. So let's do an example. This might be a little bit longer video because I had explained that, which probably made no sense to you. So we're going to graph logarithmic functions. The base thing is we identify what the base is, 6. And that's greater than 1, or not 1, and greater than 0. So we can find these 3. We have 0, 1 automatically, because nothing's being added to this or subtracted from it. And then we have this point, b, comma, we plug in our b, and we get 1 out. And this is actually backwards, 1, 0. Because remember when we switch forms, sorry about that. And then we have this point, and -1. So we just plug in our b here. So this point's always there, 1, 0. Backwards from an exponent. Remember, exponent 0, 1. Okay, so our b is 6, so this is just 6, 1, and this is just 1 over 6, -1, and then 1, 0. So then we can just graph those. 1, 2, 3, 4, 5, 6, 1, 1, 6, which is like maybe right there, -1, and then 1, 0, 1, 0. And then we just make a smooth curve, and we keep on going, get closer, but we never cross that line. And then we keep going up like that. And so our domain doesn't cross at 0, so we can do 0 to infinity, or our x's are 0 is, it doesn't hit 0, right? So that's means this, and we just keep on going to infinity, or we can say all x is such that x is greater than 0. Okay, so that's our domain, our range, let's get some space. Range, it just keeps on going down, keeps on going up, so all real numbers, or you can say all f of x, f of x such that y is from negative infinity to positive infinity. You can say it like that, or you can say negative infinity to infinity, or all real numbers, r with a line bar through it, like that. What else do we want? End behavior. So end behavior is as I go further out of my x's this way. So as x goes to infinity, what's my y values doing, or my f of x's? Well, those are just getting larger and larger and larger. So they go into infinity. Now the thing here is as I go left, well, I can't go left more than 0, right? This x equals 0, I can't go past that. I can't even get there actually. So as I approach 0 from the right, so that'd be going this way from the right, That's where that plus sign is there. So you probably haven't seen that before. My f of x's go to negative infinity. That line goes down. So that's probably something new. So hopefully you can do that. Just find your base. Let me pause this. I'll give you a problem you can do on. Okay, so there's a problem that you can do on your own. Identify what your base is. Once you know what that base is, then you can write these problems or points. And then b comma 1. And then 1 over b negative 1. Once you have those points, then you can draw your smooth curve. And then you can label your domain, your range, and all that stuff.